Good day, everyone. I'm Glaucia. I'm a third-year PhD student at the University of Waterloo in Canada. And today we're going to talk about a cognitive and machine learning-based software development paradigm supported by context. I want to thank you all for being here and watching this presentation. And I also want to thank my collaborators, Professors Alencar and Cowan. Advances in the use of cognitive and machine learning-enabled systems fuel the quest for novel approaches and tools to support software developers in executing their tasks. First, as software development is a complex and dynamic activity, these tasks are highly dependent on the characteristics of the software project and its context, and developers need comprehensive support in terms of information and guidance based on the text context. Second, there is a lack of methods based on conversational guided agents that consider the cognitive aspects, such as paying attention and remembering. Third, there is also a lack of techniques that make use of historical data about the project to infer new knowledge about tasks, such as related tasks, the task experts, relevant information needed for task completion, and warnings, and navigation aspects of the process, such as what tasks to perform next, and an optimal task sequencing, for example. Based on these challenges, this paper introduces this novel paradigm for human-machine software support based on context, cognitive assistance, and machine learning, and briefly describes ongoing research activities to realize this paradigm. This research takes advantage of the synergy among these emergent methods provided in context-aware software processes, cognitive computing such as chatbots, and machine learning such as recommendation systems. This novel paradigm has the potential to transform the way software development occurs currently by allowing developers to receive valuable information and guidance in real time while they're participating in projects. As a motivating example, let's suppose Gabby is a software developer who has been working in Java for many years. And she has recently worked in Project X, which is a new project for the company. So when there's a new project, Gabby needs to create an MVP, a minimum viable product, to show her clients. The deploys of this software, this type of environment, occurs locally using a container tool such as Docker, and Gabby manually uploads the project to a web server. She also reboots the server manually after each deployment, so the changes are effective immediately. This way is faster, and she does not have to configure a continuous integration pipeline, for example, just to deploy an MVP, and she can deliver this MVP for her clients faster. In contrast, there's Project Y, a mature and huge project in the company that Gabby works mostly and spends most of her time in her work working in this project. And the deployment tasks for this project are a little bit different, as the only thing Gabby has to do is to commit the code from the local repository to a shared repository. Then this continuous integration pipeline in the Jenkins tool, for example, will take care of all the other steps, such as building the project, uploading packages on the server, and rebooting the server too, for example. In theory, the steps are the same, but because the projects and environments are different, Gabby's work is different too, right? So this means that in the second case, the solution should be expecting project information or the project phase information to know what to do in deployment. So Gabby should know what to do when she's going to deploy. And because she has been working in Project Y for years now, she may forget how she needs to deploy Project X, the task that she has to do manually for that server, and for example, to reboot the server. So having an intelligent cognitive assistant that could support Gabby, she could be supported in many ways, such, for example, giving her the necessary information of the server she has to copy the files to, her login information, the folder she has to copy the files to, for example, and the link to the deployed system. So imagine Gabby is interacting with a chatbot and does not remember exactly how to deploy a new project. Since she's not always working in new projects, she works mostly in this mature project of the company. So in this figure, we present an example of a conversation that could occur between Gabby and this chatbot during deployment. To reach this desired level of support, the chatbot should know that her context, which includes the server address and folder of development project, for example, that could be a history of tasks previously executed in that context. So the chatbot should be able to learn and recommend the task sequence that Gabby needs to follow, and also provide the required information to execute the tasks that she wants to execute. In this paper, we present this envisioned paradigm for a chatbot that knows the software development context and relies on machine learning and techniques and history analysis techniques to support developers when executing their tasks. The purpose of this research is therefore to capture this context and feed back useful project information to developers through recommendations. Processes based on machine learning and communicated through a chatbot could lower this cognitive load of developers, could provide context-aware and real-time support for task execution, and guide developers in the development steps, such as deployment, for example. This image illustrates the envisioned architecture of the solution. So on the top, we have the developers interacting with a chatbot, both providing and getting information from it. And the chatbot is receiving the recommendations from this entire architecture that we envision that should be built, that has a database of context and process information connected. And machine learning algorithms and supporting algorithms should provide the recommendation and the connections between the context and the process information needed. We anticipate this approach to be developed in many, many different software development scenarios with tools and procedures that explore the reuse of information on software development and providing support and automation to recurrent tasks, so developers can focus on the creative aspects of development, on the use of programming languages, data structures, or other product-related concerns as well, or other user-focused solutions. This paradigm builds upon our previous work on reusing relevant information to support developers in executing their tasks and the relevance of context in software development. And to realize this collaboration paradigm based on the steps, we believe that the following research activities should be performed. The first one is the software development context research, where we believe it is essential to understand and capture this context so that adaptive context relevant to software development could be leveraged. And questions include, how can we deepen the use of context to guide developers in real time? The second one is the environment developer interaction, where these tools, such as chatbots, they should be investigated and leveraged in a way that they can provide the support to developers, and they should be supported by a context model as well. And questions include, how can we establish a communication channel between developers and their environment? A third step should be the knowledge-intensive process guidance, where knowledge workers, such as developers, they rely on their minds and creativity to implement software solutions. So providing smart solutions when building software is expected. So developers must not worry about following patterns, processes, and adjusting to project needs, as this information should be readily available to them. So relevant questions include, how can we leverage this process information to guide developers in what they must do? And the last one should be perform experimental studies to verify the acceptance of this new way of developing by software developers. To conclude, we presented this novel paradigm to improve the work of software developers by providing contextual information about the tasks through cognitive and intelligent support. It employs capturing the implicit context and feeding it back to developers in a useful way through recommendations. And we believe that developers still lack this guidance given the current context, and we should focus this research in to consider current contextual information to provide assistance to developers using chatbots and machine learning, as this can lead to less time to develop software, less effort to share knowledge among team members, enhanced collaboration, application of collective wisdom, and knowledge transfer as well. We invite you all to read the paper, and I'm ready to take your questions. Thank you very much.
Okay, hello again. The third paper of the session, Deep Neural Networks. So the paper is a cognitive and machine learning based software development paradigm supported by context, new ideas and emerging results paper. And Glaucia is here to answer your questions. I can also start, by the way, while waiting for the questions.
Okay.
So this chatbot or the devbot concept, probably you also know, but I saw it in one of the issue tracking systems. Probably it was in Bugzilla. The chatbot was fixing each issue report. So it was checking, that whether it's a bug or a request, and then it was suggesting, okay, this is probably not a bug, but it should be labeled as a request. So hearing also your talk, I was thinking, do you think that we need specific bots for those specific tasks?
I do think so. I think that everything that can help would be welcomed. And but in this case, it's a very specific thing, like labeling, right? And it also helps, it guides developers, because it's a really mixed, and developers, like, we're always doing a lot of different things, working in different environments. So yeah, I think the support is valid. It's super valid. And in the case of this proposal that I'm presenting, it's more about guiding the steps, right? Okay, so what should I do next, or how can I do it? How can I do something? And less about automating stuff for developers. That's also something that I'm investigating, how much developers like to have their tasks automated or not in another work.
Okay, so we have questions. One from Matthew. What are your early thoughts on evaluation strategies? How do you plan to measure accuracy?
Yeah, so the first thought actually is designing the prototype. So that's the next step. Right now, we already have something that works with simple processes, but now I want to choose something in the development pipeline to actually validate that. So it's probably going to be deployment. I'm not sure yet, but the idea is that first of all, to do a qualitative study, and then second, we have the data set problem, right? I have to have a data set, and we have a connection with a small company that might support us with that. But that's the idea, to go in a company, to have people using at least for one small process part, right, of the pipeline of software development, and evaluate according to the context that we can capture, and the data set that we can get as well. And that's the idea for so far.
Okay. Another question from Grace. With respect to the chatbots, what software artifacts and data sets do you envision to use as training data to provide context? How dependent will it be on the specific developer task?
Yes, it will be, according to the design that I have so far, it's going to be very dependent. But the idea is also to right now to watch that. Once I focus what the pipeline of development I want to get, I think I can think of making it a little bit more flexible, so I can also capture, for example, context that I didn't foresee. That's one example. And about the training data set, it's, as I said, like I do envision to deploy this in an industry scenario to be able to have the data set. Or in a university scenario as well, like in a classroom. That's also one of the ideas.
Yeah, if it's like a project-based course, and then
Exactly.
they use pipelines, and
exactly.
it might be useful. Yeah. So we have 9 seconds now. If there are any more questions, you are all
Yeah.
welcome to the discussion room.
Yes.
Glaucia.